Hi again. Welcome to the 4911 CyberKnights software training, session 6. We are only going to talk about arrays today. Arrays are that special and they warrant that much attention. So first of all, let's review what we talked about last time. We talked about the while loop, and we used that for finding the smallest divisor of a number. We also talked about sentinel loops, where you keep going until you reach a sentinel value that signifies the end of an input or just to stop executing. And then we dealt with some random number stuff and how to use the native Java classes for getting random numbers. And then we talked about the Boolean type in more depth than we had before, and logical operators and or not. We talked about short circuiting, how Java will not necessarily evaluate all inputs of a for logical operators if it knows what the result will be based off of the first input it encounters. And then went through some various tips in dealing with Boolean values. And then talked about some indefinite loop variations, the do while loop, then the weird for syntax, and using the break statement, which is a reserved Java keyword. And then we went through a programming example for guessing a number. Today, our agenda is pretty simple. It's all arrays. So we're going to start with basics, move on to advanced stuff, and then some really interesting stuff with a multi-dimensional arrays, which can be kind of mind-blowing or confusing, or at least it was for me when I first learned about it. But we won't spend that much time with multi-dimensional arrays. And then we'll have another programming example. Okay, so arrays, what is an array? An array is just a structure that holds multiple values that are all of the same type. You can think of we'll get to how they're stored, but the values that are stored in an array are called elements. So an array has multiple elements, and they're all of the same type. So if we're trying to deal with multiple values in Java, we can kind of start to see code like this, where we have like double temperature 1, double temperature 2, double temperature 3, and this might go on for like a bunch of different variables. I've stopped myself at 3 to fit it all on one slide, but you can find yourself sometimes writing code like this. And when you do, just remember the DRY, the dry principle, don't repeat yourself. And there's a way to avoid repeating yourself in this sort of situation. You should use an array. These are all different values of the same type, and they're all related. They should all go together. And so in this case, let's create a double array. And that's what these square brackets signify here. This is an array. The type of this variable is double array. So it's sort of like a one type and also an array. That is the type, double array. The name is temperatures. And then when we create an array, we use the new keyword, and then we use the type that the array stores, and then we use the square brackets, and then within those square brackets we give it a size. In this case, we're creating an array of size 3. Keep in mind, when you create arrays, they are objects. They are and array variables, because of that, are references. They are not values. So remember, like with references, or when we have a reference, it's pointing to somewhere else in memory, some chunk of memory where our actual object is stored. At the variable itself is just a reference to that object. And in this case, the object is an array, and within that array are values. In this case, we have 3 values, and they're all 0, because if you don't initialize the doubles, that's what they're going to start out as. Arrays use zero-based indexing, just like in strings. So if you want the first element of an array, you're going to give an index of 0, and this is how you do it. You use the name of the array, and then the square brackets, and then within the square brackets you give it the index. So if I wanted to write to the first element of this array, then I would say array name, and then the brackets index of 0, which gives me the first one. And then I can write directly to that place, to that spot, by assigning values to it. And that's what I've done here for the 3 different elements of this array, I've set values to them. And after this code is executed, this is what the memory would actually look like, where we have the temperatures variable. That's a reference pointing to the object out in memory. The object is an array and it has 3 values in it. So yeah, what can you do with arrays? Well, you can do lots of things, but if you're going to do things with arrays, loops are really good and really helpful. In this case, we have a number array of doubles. It's like 100 numbers long, and we want to like assign to each member or each element of that array some number that we get by calling this method getNextNumber. And that would be really tedious if I did like 100 different statements. And so what you can do is just use a for loop, because we know that the first index is going to be 0. So we start at 0. So I is 0, and that's where we're going to start assigning values. And our test is going to be I less than numbers.length. Each array has this built-in variable called length, and it does exactly what it says. It tells you how long, how the size of the array. So if we have this line here where numbers equals new double 100, the length is going to be 100. And we want our test to be less than length, because we want to stop just shy of 100. We want to be at 99. 99 is going to actually be the 100th element of an array, because 0 is the first. Yeah, and this is how you could very easily initialize an array using a for loop. Arrays have bounds. You can accidentally and very commonly find yourself trying to get an element within an array that's not within the array bounds. So like I said earlier, or like I said on the previous slide, this creates an array of size 100, and the last element of that array, the index is 99. If you try to get the element at index 100, it's gonna crash. And if you likewise try to get it at the index is -1, that doesn't mean anything. That's nonsense. That will also crash. And the crash that you'll get is this very helpfully named array index out of bounds exception. And then there'll be a error message that tells you what you did. Index 100 out of bounds for length 100. So that's what you would get if you did this 100 index. Now, as a side note, this is actually a very important like a security enforcement, because in some languages that don't have such tight protections, you can actually like write outside of an array. And what, like I said earlier, that the array is just like sitting out there in memory, and that has a bunch of values in it, and they're all grouped together. In some languages, if you just go to like index 100, it will go to the next place in memory next to the array. But that memory doesn't belong to the array, and the language will just let you do it as if it did belong to the array. The problem with that is that memory might be being used for something else, and now you've suddenly like overwritten someone else or some other object in memory, and that's when weird stuff can happen. So Java enforces tightly that you don't use indexes that are outside the bounds of the array. Arrays are really useful for things like getting an average set from, or getting the average of a set of numbers. So here's a quick little code snippet where we sum up a bunch of numbers, and then at the end we get the average by taking the sum and dividing it by the total numbers. But here's a question: how many numbers in that sequence were above average? Well, we don't really know, do we? Because when we got the numbers, we just added them up, and there's no way to backtrack in this code here. This getNextNumber method, as we've talked about before, is sort of mysterious. It just gives us the next number in the sequence. We can't go backwards with the getNextNumber method. It's always going to get us the next number. So what do we do here? Well, let's use an array. And so here's the same sort of, initially the same sort of code with the additional component, or the additional wrinkle that we're actually storing the numbers in this array that we've named numbers. So we create the double array, and the size is going to be total numbers. And then we go up to the numbers.length, we populate the array, And at the same time, we're also creating our cumulative sum. After that, after we've done all of that, then we get the average, but we want to know how many of those numbers were before or were above average. Well, now we can go back through those series of numbers because we stored them in an array. So we go back to the beginning and we go through the whole array and we check to see whether the current number at the current index is greater than the average, and then we increase our above average integer that starts at 0. And at the end of this, we should know how many numbers were above average in that sequence. So we do go through the sequence twice, but that's just kind of unavoidable in this case because we don't know the average until we've evaluated all the numbers. Okay, and so this raises an important concept, or all this talk about arrays rather, raises an important concept, and that is sequential versus random access. When we're talking about sequential access, we're talking about manipulating values in a sequence from first to last. So that method that we've been talking about, this get next number method, this isn't something that's built into Java. It's just sort of this theoretical method that I haven't really written yet, but that would be an example of a sequential access thing. It's going to give you the next number each time. You can't jump ahead 2, you can't jump back 1. It's just going to get you the next one. Reading files is typically sequential, not always, but if you're reading from a text file or some input files, usually looking at one part of the file and then you read a few bits or bytes, and then the place where you're reading moves along sequentially from the start of the file to the end. Arrays, on the other hand, are random access, and that means you get to manipulate the values in any order you want. Not only that, but it's quick, regardless of where you're looking at. And like I said, arrays are random access. Data that's stored as random access is usually grouped together in one long block of memory. When you're dealing with arrays, keep in mind that arrays are objects, and unlike string objects, arrays are mutable. Strings, as we talked about earlier, you cannot modify a string once it's been created. You can just combine it with another string, and then when you combine those strings, it creates a third string, and those are all different objects. You haven't mutated anything. Arrays, though, you can mutate them. And because of this, you don't need to be returning an array that you're modifying. So looking at the sample code here, we have a what we do is we create an array of doubles of size 100, and then we have this init array method that just takes as a parameter the array, and then calls that get next number method and populates it. And then at the end, we return that array. And this may seem like, oh, well, I create the array and then I initialize the array and then assign it to this variable here. You don't really need to do this. In fact, this is confusing because if you look at this code, this looks like these are two different arrays, and they're not. These are both references to the same array. We've only created an array one time here, the new double array, and then we pass it in here. And then at the end, we return the number, or return the array that we've been modifying. So these are both references to the same object. And because of that, I wouldn't recommend returning arrays that you're modifying. Just assume that the user or the person passing it in knows. And this code here is logically identical to the previous code. We create the array and then we pass it into a method that's a void method. It returns nothing, and that initializes it. This is much more clear what's happening in this code. You really shouldn't return something unless you created it within the body of the method. There are some important limitations to arrays. One very important limitation, even though arrays are mutable, the sizes are fixed. When you create an array, you give it the size, and you cannot change its size from thereafter. In order to resize it, or to sort of conceptually resize it, you have to create a different second array that's larger, and then copy everything over, and then start using the second array. You can't compare arrays with the equals equals operator. Remember, they're objects, and equals equals does not work with objects. For object equality, you have to use the dot equals method. And if you ever try to just print out an array to the console, like you do a string or an integer or a Boolean value, you'll get kind of gobbledygook. You won't see all the values that are inside that array. You may think like if you have an array of numbers and you print it, you'd like to see all the numbers. You're not going to see the numbers in the array. Okay, so let's talk about some advanced array topics. So here's a somewhat difficult problem. How do we shift values? So we have an array and we'd like to move every value left. That's what this code here does. So if you look at the code, I take the first temperature and I store it in a variable, and then I shift the second one to the first, the third one to the second, and the fourth one to the third, and then I take that first variable that I created and I assign it to the fourth. Quick question though, like why in this code does it copy the first one first as a first step? And if you think about what would happen if you didn't do that, if you just sort of started moving things left, like if you took the first one and moved it left, okay, and then you move the second one and moved it left, and then you move the third one and moved it left, and then you take the first one and move it back to the third. The problem there is that by the time you get to the end of the array, the first one has been overwritten by the second one. So we need this extra step here to temporarily copy what's inside the first index of that array, just so we don't lose it when we immediately overwrite it with the second element. Okay, so let's actually do this as a exercise. Okay, so what we're going to do now is we're going to write the actual code for shifting an array, and here I have a little helpful illustration for what we're trying to do. So you can imagine that we have this array and it has the elements in it of 3, 8, 9, 7, and 5, and then we shift all of those left, and you can see that in the second list down here. And then the first value gets copied to the end. So we've done that by like individually indexing each element of the array, but we want to do it in a cleaner way and a way that adheres to our DRY principle where we don't repeat ourselves. So we're going to use a loop. So let's start out with this shiftarray.java file, which I've already created, but it's just blank. And we know what we need to do initially. We have to create a class, public class. Everything has to live in a class, and we're going to call it shift array because that's the file name. And currently the class body is empty, but we want it to run a main method. So we know that the magical words there, public static void main. And then this thing here, which guess what? That's an array. So yeah, we've kind of demystified, at this point, we've kind of demystified what this public static void main string array args means. So it's a public method, it's static, which means that it can be called anywhere. It's not it's not part of an object, it's part of the class itself. It's void, so it has no return value, it returns nothing. The name of the method is main, and that's a special name that Java will look for during runtime to see if you have a main method. And then this parameter here, args, is short for arguments, and its type is string array. It's an array of arguments. So if you are starting a Java program at the command line, you can actually pass in arguments, which will be converted into strings, and then from strings you can try to convert them into integers if they're actual numbers or something like that. So when someone's running your program, they can actually pass in things like messages, numbers, flags, and you can interpret them how you want. We're not actually going to do that, but just so that at this moment, this is no longer a magical incantation. We've memorized it, but now we actually know what all these things mean. So that's cool. All right, so what are we going to do? Well, let's actually start by writing a little bit of pseudocode. We know that we're going to copy like the next item of an array into the previous the next slot of an array into the previous slot. But let's kind of figure it out. Start by saying like we'll put it in a multi-line comment, so then we won't get tripped up by the compiler. For each array element, we'll make this look like a for loop, although that's not quite correct for loop syntax. It's fine, it's pseudocode. We get to make our own rules. Copy the next element to this element's position, right? So let's try to figure out if we can clarify what this would mean. What does it mean for each array of an element? Well, we can either use our for, well, let's just index it. So we actually know how to do this. For int I, and because arrays are 0 indexed, we want to start at the first index, which is going to be 0. That's the first position. I less than the array. Well, let's call this array.length. We haven't created the array yet, so this won't compile, but we'll say that our array is called array. And then I plus plus. Okay, and what do? Well, we say the current element is going to get the next element, I plus 1, right? That'll be the next one up in the array. So yeah, we go through the whole thing. Well, let's see if this actually works. Let's put up here above our pseudocode some initialization for an array. So we'll say int array, so our type is, it's an integer array, that's the type, equals new int array, and we'll give it a size using our sample. This is 1, 2, 3, 4, 5 items, so the size is going to be 5. And then we have to kind of do the tedious initialization. So array of 0 is going to equal, so it's 3, 8, 9, 7, 5. So 3. And it's going to be 8, 9, 7, and 5. Now let's change our indexes to make them go up. So 1 will be the second item, 2 will be the third item or element, 3 will be the fourth element, and 4, index 4, is the fifth element. So that's an array of size 5. Let's see what happens. First of all, let's print out the array by going through it using a for loop. So I'm actually just going to copy this for loop because we know this is sort of boilerplate. You start at 0 and then you go up until 1 less than array.length or I less than. This is the same as saying less than or equal to array length minus 1. But by convention, just to simplify, we use I less than array.length. Let's print it out. System.out.println, and we will say element, at index, and we'll print out the index, is, and then we will append the actual element, so array I. Okay, and then we have our statement terminator. Great, so we print out the whole thing here, we shift it all here, and then we print it out after it's shifted. And maybe we'll say something like system.out.println shifted array. And we'll say just array up here. Now at this point, I see that my indentation is off, which is annoying, so let me go through and fix this. Whoops. Okay, cleaned up the indentation. Let's try compiling. Java C shift array.java. Okay, it looks like I've missed something. I've left off a parenthesis. Okay. It looks like it's line 13, but I can just look for this statement right here. System out println element at index I. Okay, element at index I. Oh, well, I have, so I take this string here, element at index, and then I append I, and then I left off the operator to append this string here, and then, okay. So that's what I left off, is the plus thing to append to the next part of the string. Okay, it looks like I have a, oh, well, yeah, because I copied and pasted, it's gonna, the error is gonna persist down here as well. Great, now I'm getting a little bit closer. So line 13, it says a semicolon is expected. So what this means is typically when you see something like that, an error message like this, that doesn't make a lot of sense. Very often it means you've done something wrong on the previous slide, and it looks like I actually accidentally inserted an S when I was trying to save. All right, let's run our shift array. Okay, so we start and print out the array elements 38975. So 38975, that part was correct, but then we see an error. Index 5 is out of bounds for length 5. And the reason why we're seeing that error is because of this loop right here. So I am going from 0, which is the first element, up to the end of the array. But if you look at the end here, where the index is 4, and I'm looking at the 5th element of the array, I'm trying to copy to it the element at index 4 plus 1, which is 5. So I'm looking ahead with this next step. And that's not going to work for an array because it ends at length. So, whoops, -1. So I want to stop early. That should work. But this is going to cause a separate issue. Let's see what happens. Compile, run, whoops. Okay, so the array is 38975, great, and then the shifted array, 89755. What happened to our 3? Well, we did stop early, but then at the end of the array, we needed to copy something to the end of the array. So we want to copy the first element. After we go through the whole array, then we need to deal with the one at the last index. So array, let's make this a variable. Or actually, we'll make it a class constant. So public static int, and we will call it length equals 5. Actually, I don't need to do that. I'll still leave this as the class constant, but I can just do array.length -1. Whoops. I'm making all sorts of typos here. Array.length -1. And the reason why this works is that I know that the length is going to be, like, if the length is 5, then the last index is always going to be 1 less. So this array is size 5, and that means that the last element is at the 4th index. So that equals, and I want to copy to that the item that was at the start of the array, but I can't do that because the start of the array here has if you look at it, the start of the array has been copied. We can see it on our output here. So the start of the array was 3, and then after we do our shifting, the start of the array has been overwritten. So before I run this loop, I need to get the first item. All right. And then at the end, after I run the loop, I need to copy that first item to the end of the array. Let's see if this works. Okay, compiling worked, running it. Okay, 38975, 89753. Okay, so yeah, that looks like that worked just fine. Yeah, let's try like an arbitrary sized array. So what I'm going to do now is I'm going to say like I'm going to say that the array is going to be of size 20. And then here, I'm actually, where I initialize the array, I'm actually going to say I0, I less than array.length, I plus plus. And instead of doing all this, I'm going to say the item at I should become, I don't know, we'll say I plus 1. And then we'll say like times 2. So what this means is that like the first element should be I plus 1, which would be 1, times 2, which is 2. The next one should be 4, 6, 8. All right, so we start 2, 4, 6, 8, 10, 12. Looks like we're counting by 2s all the way up to 40, which is good because our array size is 20. And then when we shift the array, it looks like, yeah, we 4, 6, 8, so on and so forth, all the way up to the second to the last element, which is 40. And then our last element is the previous start. Okay, so we can change this to really anything, and it should still work. You know, we may not want to read the whole output here, but we've successfully created a program that can handle very large arrays without having to write a bunch of extra code. And we no longer need our pseudocode because we have real code. Great, cool, awesome. Okay, back to advanced array topics. So initializing an array, you can, as we've talked about before, you can access the elements of an array using the index, and you can initialize it using a for loop. But if you had like a set of numbers here that were predefined, like this is only 5 numbers, and these are maybe like constants or something, we couldn't really do this with a for loop for whatever reason. This is the way that you would initialize this array, but this is via a total violation of the DRY principle. We're doing something very repetitive. It's a bunch of lines that look very similar. And so Java allows you to avoid this repetition by giving you a different syntax for creating a new array. And that's this syntax here. You have the curly braces, and then you have all the values, comma, separated. This is the same, these are logically identical. This single line of code is the same as creating a new integer array of size 5 and then populating each index with these corresponding values. Now keep in mind, this helpful syntax is kind of hiding the fact that an object is being created, even though you don't see the new keyword or the constructor being invoked. This is still a new object when you see this syntax. A new object is being created. All the way back in our first session, we talked about how the Java class libraries have a lot of built-in helpful code. Well, dealing with arrays, yeah, that's also something that the Java class libraries can help you with. If you want to sort a sequence of numbers, there's this very helpful class called arrays, and it has a static method called sort, where it accepts as an input parameter a number array, and you can just sort those numbers. And so if you call this method with this array, it won't return anything. Your number will, or your numbers array will be modified to have all of the elements in sorted order. This is really useful and really helpful, especially like if you're maybe writing a word game solver or an anagram solver or something like that. Okay, so another important concept is arrays of objects. Up until this point, we've been talking about arrays of primitives, but arrays are not limited to primitives. You can create arrays of objects as well. And so previously we dealt with this point class with point objects. The syntax for creating an object array is actually identical to the syntax for creating a primitive array. You just use the type here with the brackets, and that tells you this is a point array type. That's the type of the points variable, point array. And then when you're creating it, you just do new. That's a new object. And then within the brackets, you give it a size. So everything here up until this point has been, we've seen before, it's now a capital letter because this is an object instead of a primitive. However, one of the important things about objects is that when you create an object array, it won't create the actual object elements within the array. So you're going to have, after this line of code, you're going to have an array, a point array of size 3, but at each index of that array is nothing. It's just empty. If you try to print out what's at a specific index, it's just going to give this word null. And null is a special value in Java, and it means that there's nothing there. And so if you want to create a new point array, you would have to do this, where you create the point array and then you populate each index with a new object. So you can see 1, 2, 3, 4. There's 4 news here. So there's one new point array, and then there's 3 new points within that point array. Or you can use the syntax where we use the curly braces. So the same sort of thing that we saw earlier with integers, only you have to invoke the constructor for each element that you're putting in that array. So this single line here is logically identical to these 4 lines above. However, it starts to get long and long and long. I wouldn't necessarily recommend using this syntax unless you had a pretty limited size, like, only a few objects. All right, so even more advanced topics, multidimensional arrays. Multidimensional arrays are an array of arrays, and the elements, in order to get an element within a multidimensional array, you have to specify multiple indexes depending on the dimensionality of that array. And the number of dimensions is technically unlimited. You can just keep on going. This is really useful for representing things like tables or matrices. Pushing it beyond there, like I'm not sure you would want to go beyond 3 dimensions, but you totally can. And so here's a helpful, when you're looking at code, here's some helpful guide, I guess. If you see like just the type, it means, okay, this is one double. If you see a double like this in the code, if you see double with square brackets, oh, that's an array of doubles. If you see double with 2 sets of square brackets, oh, it's a 2-dimensional array. Or a 2-dimensional grid of doubles. And then if you see like 3, oh, it's 3-dimensional. And you can keep going. But it gets more and more confusing, and I wouldn't necessarily recommend it because it makes your code hard to read. It either signifies that you're doing really advanced math or that you're writing really confusing code. Okay, so here is what a 2-dimensional array would look like. This is 2-dimensional arrays. You can think of them as like tables or rectangles. Think of them as having width and height. Each row is the same size in a 2-dimensional array. That's why it's sort of rectangular, or why we talk about it as being rectangular. And to create a two-dimensional rectangular array, you would just use this syntax where you have like double bracket, 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 bracket. That means it's a 2D array. And then you give it size for each dimension, so 3 and 4. So in this case, you can think of it as having 3 columns and 4 rows. And because this is a double, this is a primitive, it will populate it with initial values of 0. When you try to get the elements of a two-dimensional array, you have to specify both indexes, and you can kind of like the first index is conceptually rows, and then the second index is conceptually like the element within that row. So looking at this temperature 0, 3, you're getting the 4th element of the first row, and likewise here you're getting the first element of the 3rd row. I almost said second. There is an important like clarification here. If you see like temperatures, if we're dealing with like this array here where we have double and then bracket, 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 bracket temperatures, it's a 2D array. If you use the word temperatures, that refers to the entire thing, the whole grid. If you're using this temperatures and then brackets and giving it 1 index, that will get you the entire row at that index. So this will get you an array of doubles. Temperatures with an index of 2. It'll get you the 3rd row. It'll give you like 1, 2, 3. This row right here, it'll give you a one-dimensional array of doubles, and it'll have those 3 elements in it. However, if you specify both indexes, that gives you an element in that array, a single double element. So this is the first element of the 3rd row. So yeah, the first element of the 3rd row. Our 3rd row is here, and our first element is right there. Great. Cool. Lastly, we have jagged arrays. Jagged are called jagged because they're not symmetrical. They have multiple dimensions, but the rows can all be different sizes, and because of that, you can't use the helpful like 2 size initialization. You just create the you pass 1 integer in for the first dimension, and that gives you the number of rows. But then the columns are dependent on what you specify for each row. So here we've created a jagged array that has 3 rows, and then in the first row we say, well, it's got 3 columns. Only I think I've done, oh no, it's got 2 columns, sorry. It's got 2 columns, which I've illustrated correctly here. And then the second row has 4 columns. And then the 3rd row has 3 columns. Now jagged arrays aren't especially useful. They can be useful for certain applications, but you have to be really careful when you're indexing things in a jagged array, because calling, in this case, you can get the element in the 3rd element in the 2nd row, but you cannot get the 3rd element in the 1st row. That will give you an array index out of bounds exception. So use these with care. They can be useful for like storing a list of numbers, and then like a list of numbers. But if you find yourself doing that, there might be a better way of actually representing that data. All right, at any rate, we've reached the end of the actual slides, and it's time to go to our programming demonstration. Well, let's do our programming exercise. And so the programming exercise is going to, this time, is going to be to examine this file right here. And I've named this file hours.txt. This is just a plain text file, and within it are a bunch of numbers. And what these numbers represent are hours that someone has worked. And each row represents a week. So this would be the first week, and then the second week, and so on and so forth. And then each column represents a day of the week. And we'll say that the first one is Monday, and the second one is Tuesday, and then Wednesday, Thursday, Friday, and then we'll do Saturday and Sunday, because the work week begins on Monday. And so what we want to do is take this entire, or to read this input and as an output, we want to print out the totals for each week. And then we want to print out the totals for each day, like cumulative totals for each day for all 7 weeks. And then at the very end, we want the total, like all hours worked for all 7 weeks. Okay, so let's get started. We know that, well, I've already created this file called hoursworked.java, and I've used the capitalization, the camel case as you're supposed to. So, but we know that our code has to live in a class, so we've done this many times. Public class hours worked. And then within here, we need a main method. Public static void main string array args. We know what that means at this point. That's great. And then we're going to read the file. Now, reading files in Java isn't that hard, but it isn't something that I've gone over with you just yet. So really briefly, what we have to do is we need to create a file object. So we'll do file, and we'll call it file, and make a new file object. So we're invoking the constructor. So that's what that means, new and then file. And the parameter that we use for this constructor is a string, and the string is the path to the file. And since this one's in, I've saved this text file in the same directory that I've saved this Java class, we don't have to give the full path. We can just say the file name itself. All right, so let's compile it. And see what happens. And right off the bat, we've got a problem. It says error, cannot find symbol. It's because I'm using a class that I have not imported. So the file class is a native Java class, and it lives in the IO, and that's for input-output package. Okay, so now we're able to open a file object, and the next step is to create a scanner object. We'll call this one input because it's our input scanner. And in one of the constructors for scanner, and that's what this is, new, so we know that's a constructor, it accepts as a parameter a file object. So we'll say file. Before I make the same error I made before, let's import java.util.scanner. All right, and let's compile. We've got a problem here, though. You can see it says unreported exception, file not found exception. What that means is that this constructor here for scanner will throw an exception if it can't find the file that we've passed in. And that could happen if the file gets deleted or if I do a typo here or something like that. And so what we need to do is make a decision right now on what we're going to do. I'm not actually going to keep prompting the user. In fact, I'm not prompting the user at all for the input. So I'm actually just going to crash if that file can't be found. You want to maybe do something a little bit more gracefully, like tell the user to give you a different file name or something. But in this case, I'm not going to do something quite like that. I'm just going to say just crash. And the way that you do this is by using the throws keyword and then what type of exception it throws. File not found exception. So if we encounter that exception, we're just going to throw it up the chain and it's going to crash our program. We also need to import it. It lives in the same place as IO, or as the file class, which is the java.io package. So compile, great. Our compilation passes. And so the next thing that we want to do is we want to start processing this input. And I think the logical way to do that is to go through it line by line. And then for each line, then we want to total up the days for that week. And at the end, we're going to want to be able to keep track of the days for each week too. So I think what we need to do is convert each line into an integer array. So let's create an initial method just called process input. And this is a method we're going to write, and it's going to accept as its input a scanner parameter. And so here's that parameter, and we'll also name it input here as well. Remember that we could name it something else. It would still be the same object being passed in. This is a different reference than this reference, but it's a reference pointing to the same object that's only been created once. All right, and so what we want to do is go through this scanner line by line. So we'll say like while there are more lines, process the lines, and then after, well, we'll just do this step initially. So we just process the lines. So what does it mean that there are more lines? Well, helpfully, scanner actually has a method called hasNextLine that returns true if there are more lines. And what do we want to do? Well, we want to process the lines, or process, I guess, the line, since we're in a loop. So we'll just say string line equals input.nextLine. And that means we need a new method, public static void process line. And this will take a string that is the entire contents of one line of this file. So yeah, what should we do? Well, let's start by printing it out. This isn't what we want to do eventually, but let's just initially print it out to make sure that we're reading the file correctly. Whoops. Okay, it looks like if I compare this output, the terminal output, to my file, it looks like I am successfully reading and printing out the lines. So I've accomplished almost nothing at this point other than to like mimic what the file is doing. But what does it mean to process a line? Well, I think what we want to do is what we've already said we're going to do. We need to convert this into an integer array. So let's initialize our, we'll start by like create an array, and then while there are more numbers in the line, add the next number to the array, and then at the end we want to return the array. And so that means a couple of things. First of all, we're no longer void here. It's going to be an integer array. We know how to create an array. Whoops. Whoop. Okay, so our type here is integer array, and we've called it array, and then we create the new array. But what should its size be? Its size should be 7, but 7 is what we would say is a constant. So let's create a class constant here. Public static final int days. And then instead of like copying the number 7 around a bunch of times, we'll just say days. While there are more numbers in the line. So helpfully, what we can do is create a scanner on the actual string that represents the line. And then we can ask this scanner, are there more numbers in the line? So dot has next int. So yeah, that's what that's saying. So if there's another integer in the scanner, then we add the number to the array. So how do we add a number to the array? Well, we say array at index, but we don't know which index yet, equals line scanner.next int. This is another method that exists on scanner. You can ask if there's another integer, and then you can get another integer. But here's the problem here is we don't know what index we're using. Well, we know that for arrays, the index starts at 0. And we know every time we get a number, we want to increment the index by 1. And then we want to return the array. Okay, so now we are processing the line. We're calling process line, but we're throwing away the return value. So yeah, we could just say integer array line array equals process line line. Okay, so great. So far so good. We are processing the input of a single line. But what do we want to do now? We have the integer array. Well, let's sum up all of that. That was our first task was to output all the hours for a week. So let's total up. We know how to total up all the values in an array. We just go through it and do the cumulative sum thing. But instead of doing it here, let's create a method that will do this. It's going to return a total that's the sum of the entire array, and we'll just call it sum. And the parameter is going to be an integer array. And what should we call it? Well, we can just call it array. And we've already seen this solution before, but let's just go through it. We start our sum at 0. And then for int I equals 0, because arrays are a 0 index, so that's the first element of the array is at index 0. While I is less than array.length, so this is going to stop just shy of length. It would go all the way to length if it was less than or equal to. And when you want to stop just shy of length, because remember the last element of the array, its index is length minus 1. And then we increment each time. And what do we do in here? Well, we just add to the sum. And that's just a plus equal. Plus equal what? Plus equal array. We want the element at index I. And then at the end, we just return the sum. Okay, cool. So here where we're processing the input, we get the line array. Let's print out the sum. And how do we want to format this? Let's say it's like we'll just say total. And then we'll add, at the end, we'll append the sum of all the hours for the current week. Line array. Okay, so we've got a problem here. Non-static method sum cannot be referenced from a static context. And that is because I've created an object method and not a static method. So this has to be static since it's called from a static place. All right, cannot find symbol array. So this is at line 24, int array. Oh, it's not, yeah, this is not the correct syntax for creating a new integer array. This is the correct syntax for creating a new integer array. Typos galore. All right, So this actually, I believe, is correct. I know that the first week is definitely 40. The second week is also 40. Is the third one 32? So it's 8, 12, 20, 24, 32. That's correct. 3, 11, 17, 21, 25. Yeah, it looks like this is correct. 16, 16. Cool. So it is summing up the actual hours for a week. But now what do we want to do? Well, we needed to get the total hours for each day. We want all the hours for Monday, all the Tuesday hours, all the Wednesday hours, and so on and so forth. So what do we want to do here? Well, I think what we want to do is create another array. And maybe at this point we want to change the names of our arrays so that we don't get confused. Oops. Oh, hold on a second. Okay, so what we want to do now is get the total for each day. So we want all the Monday hours, all the Tuesday hours, and so on and so forth. And I think the best way to do that is to create an array here where we're going to store up all the weekly totals. Since this is the place where we're going through line by line, we probably want to create an array here that represents the totals for each week, and then as we go through each line, start adding to those totals. So this is going to be another integer array, and we'll call it totals. And we know it's a new integer array, and the size is days because it represents the days of the week. This is the total Monday hours, total Tuesday hours, Wednesday, Thursday, Friday, and Saturday. And then as we're going through line by line, we also want to add the total for this week to the total for the array, to the running total within that array. And then at the very end, we're going to print those out. So, well, I think what we need to do is create a method. We'll call this add total. And in this method, we're going to pass in the totals array, and we're going to pass in the current line, the current array representing the line that we're reading in the file. Okay, so let's create that method. And this is going to be void since it returns nothing. And the name is already determined for us, add total. And the parameters are going to both be integer arrays. Oops. So what did we do inside add total? Well, this one's kind of a little bit tricky, but I guess not really. We just go through all of these values and add them to these values. So we know how to go through an entire array. Let's write the code for that. For int I equals 0, I less than line array dot length. And then we want to add whatever we get at this location. So what do we get at this location? We get that. But we want to add it to the corresponding index of totals. Oops. Plus equals. So this takes it looks up the element at totals I. So this is going to start at 0, 1, 2, and so on and so forth. And we're going to add to whatever is there the corresponding element at the same index in the array representing the line that we're currently processing. and then add that cumulative amount back to it. So every time we call this, it's going to add everything that's in this array to all the values that are already in this array. And this array, when we create it, it's going to be just 7 zeros. All right, so I think this is correct. Okay, so at this point, we've added everything to the integer array here, but now we want to print out the totals for each week. And we could go through in this process input, we could go through this array, but let's create yet another method for doing this. And this one's going to be void because the only thing this is going to do is print out the totals. And its input is going to be just the totals array. We only need the one array. And so what do? Well, we process the array from start to end, and we know how to do that. And now we want to print out the actual totals. So we'll say, well, initially, let's just print out like what we get at that element. So we'll clean it up here after we've printed them. Okay, we've got a problem. So cannot find. Okay, because I've named it print totals, but then when I invoke it, I'm using print. Okay, so let's double check this and make sure it works. Is the total for Monday 43? So 8, 16, 24, 27, plus 8 is 35, and then plus another 8 is 43. Great. Okay, 8, 12, 16, 24, 32. Okay, great. 8, 16, 24, 32, 36. Looks good. Looks like it's actually totaling up all the days correctly. But we want a little cleaner formatting. We want to tell what days these are for. So let's give it a label. And we'll call, we'll just actually create an array with all the week labels on it. And we'll make it a string array. And we don't need to like go through this array. We can actually just put them in here as we know them, or as we initialize it. So we'll do Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And we're actually going to print out here labels, and we'll get the corresponding item at the correct index 0, 1, 2, 3, 4, 5, and 6, plus so that we're creating a string. We're appending. We're creating one string by appending three components together. So we start with the actual label, and then we add a colon, and then we add the actual number. Okay, so looks good to me. But the very last thing we wanted to do was to print out the total. And so we know how to go through a list, an array, and sum everything up. But the good news is that we don't actually have to do that because we already created a method that will sum everything in an array. So let's just do that, right here. System.out.println, and we'll call this overall total Okay, great. So it looks like this is correct. We've got our total hours for each week being summed correctly. We've got our total hours for each day being summed correctly. And then our overall total hours being summed. And these numbers check out. This is what I was expecting. Okay, so thank you for attending this session, and I will see you in the next one.